I'm trying to figure out how to change this information. YouTube. Let's see. Two, five. There we go. Okay. Just got to get this updated. Save. Okay. Here we are. Let's get started with our Advent code. I am quite behind. So on the calendar, I've got first I'm gonna put my music on so I can hear it. Wait a second. That's right. Don't want to stream music. Some tools. Settings. Stream. I had it set up so that music wouldn't go. Icarus music. Okay, whatever. Tools. Let's see if I can get music playing without you guys hearing it. I'm testing out. Okay. Perfect. I gotta listen to music, but you guys don't have to. And I don't have music that I want to stream. So I don't want to mess up in any of that. Let's see, we got some. Oh, yeah. Okay. So yes, let's get into streaming or into doing some Advent of Code. Now, if you want to follow along with Advent of Code or do some of your own Zig stuff in Advent of Code, we've got it up on Zigit. Every day we have an Advent AOC. We have every day so far this month. Or the first day went. Oh, there it is, day 1. But I'm going to start with day 13 and start working my way back because I'm behind. So let's pull up day 13. Next up, the lobby of a resort on a tropical island. The historians take a moment to admire the hexagonal floor tiles before spreading out. I'm guessing that's an allusion, like all these ones, to previous year, 2020, day 24. Well, you look, I did not ever get that far. 2020, I did 1 star. Okay. Come back, sorry. Calendar. Let's go with events. 2024. There we are. Fortunately, it looks like the resort has a new arcade. Maybe you can win some prizes from the claw machine. Claw machines here are a little unusual. Instead of a joystick or a directional button, you control the claw. Oh, to control the claw, these machines have 2 buttons labeled A and B. Worse, you can't just put a token in play. It costs 3 tokens to push the button A, and 1 token to push the button B. With a little experimentation, you figure out that each machine's buttons are configured to move the claws a specific amount to the right along the x-axis and a specific amount forward along the y-axis each time that button is pressed. Each machine contains 1 prize. To win the prize, the claw must be positioned exactly above the prizes on both the x and y axes. You wonder, what is the smallest number of tokens you'd have to spend to win as many prizes as possible? Use symbol delist to every machine's button behavior and prize location, your puzzle input. Okay. It costs 3 tokens to push A, 1 to push B. Okay. I'm actually going to pull up the scale draw here. Because looking at the data, it's from last video. We have some options here, I think. Let's see, draw. Green. So we have option, you have button A. Equals, and then it's gonna have some X transform, right? Some X, which is, well, I don't want to use this notation. Yeah, X has a 94 change and Y is a 34. Okay. So let's do X equals, whoops, equals 94, Y equals 34. And they're positive. In fact, all these are positive, though I assume that maybe sometime we'll have negatives. Just looking through the data. So then, and then B is 2267. B equals 2267. Okay. And we know that this costs 3 tokens, and this costs 1 token. Okay. So my first thought is, oh, and we have the prize as a location, which is equal to this first example. We've got 8,400 and 5,400. 8,400, 5,400. Okay. This should be a straightforward math problem because here we have a valid system of equations, right? We have 94. Will you say the amount of times you press A is little a, the amount of times you press B is little b. So 94A plus 22B will equal 8,400. And also 34A plus 67B equals 5,400. Okay. So then all we have to do is define, we have to figure out how to solve the system equations here. And that would be A equals, let's see, solve for A real quick. Solve for A by first subtracting, let's do 22. So 94A plus 22, or no, not plus, equals 22 negative 22 plus 8,400. Divide the whole thing by 94. So A equals 8,400 divided by minus 22 divided by 94. And we can do this real quick. Rishi. 400 minus 22 divided by 94. 89.12. Interesting. So they're saying 89.12 is the answer there. First, let's consider just the first claw machine in the list. Now they say 94. Or no, pushing A moves at 94. Pushing B moves 22. The prize is located here. This means cheapest way to win the prize is A 80 times. Did I not do that right? $94.22, they say. Oh yeah, they're doing it 94 and 22. 80 times times 94 plus, how many times did they do it? 40. 40 times 22, 8,400. So that is a solution to the equation. In fact, I guess there's a lot of solutions to the equation for that one. However, because 80 times 34. Oh. I did mess up my equations. 5280. Oh. There you go. I did mess up my equations. I need to match the x with the... No, I didn't mess it up. Because the number of times we press A plus the number of times we press B needs to add up to 8,400. And the number of times we press A and B also need to add to 5,400 when we multiply them by the steps that we're taking. 94. So when I try to solve for A, I got 80 something. Interesting. Now, they do say that there's no more than 100 times to win a prize. That each button should be pressed more than 100. So that they are telling us a limit in case we wanted to kind of brute force and try every combination. I wonder what would happen if we solved for B. Solve for B. I'd get B equals 5,400 minus 34 divided by 67. That gets me 80. 80.8. $467. Sure I got these right. 94 and 34. 22 and 67. Maybe I'm wrong. System equations wouldn't work here. I would think it would. You know what? I don't have chat up, so I can't see if someone's chatting or not. No, I do. Okay. Trying to think. What am I messing up? Or am I just wrong? It's definitely one of those questions I feel like you need to sit and think about before you can just do it. Price located at here and there. I'm thinking about minimizing this. And intuitively, if there's a ratio, right? 94 and 22. .27. So what we'd want to do, obviously, is button B is cheaper. Here, but it's more expensive here. It's all these ratios here. That's not going to work. At least not my math knowledge of it. And I know this is a math problem because I read in Zig on the Zigit, someone who did this one. Let's see. If we go here, day 13. Eric, he says people say math has no real world application. But I haven't looked at his answer yet. I don't want to look at his answer. I want to try to figure it out myself. And this definitely feels like one that has a math answer, but might be math that's beyond my level. I'm not really great at optimizing things, linear programming and whatnot. I don't think we need to reach for that, but maybe I'm wrong. It's definitely something we could do if we just hard, kind of brute forced it. We just tried. See, 1 through 100, but that'd be 100 times 100. 1,000, 10,000, sorry. Tries for every value, right? And this shows a lot of math involved. I guess that wouldn't be too hard. Just 1 through 1. Let's just do that. Let's just hard or whatever brute force it right now. Okay. So we're gonna try some vector stuff because I think that'd be cool. So let's start today. I'm going to do make day. This is day 13. So move into day 13. Day 13. And we're going to watch this. Test.txt. Test. Okay. We know that So now we're going to do on the test. Data file. Pub. Not pub. Is test. I could do something with the build system and do this. I don't really want to jump into that right now. It's out of the way. Const is test. False. True. And then we'll say const variable. Let's see, const file, data file equals if is test. Then we're going to do data slash test.txt. Else data slash prod.txt. If we're going to say answer zero. If answer or if is test it's not our answer. We're going to do standard.debug.print, do testing. But if answer if equals, and we know the answer needs to be the test 480. Else fail. Oh, double equals. Expected. do that for now. There we go. So now we'll see that we are failing. We fail. I like this construct, so I'm going to keep this. Template main. Let's test answer equals okay. So here we are main. And we're going to do some coordinates. So do const coord equals do I. Let's take a look at the puzzle input here. The ranges of the values here. I mean, they gotta be less than 10,000, right? Nope, we have more than 10,000 here. See. 16 2 16 minus 1. Yeah, that should be plenty. So if we say const I16 chord equals two it's an I16, or no, actually we're going to use 16. How much is I16? I'm going to build out a whole bunch of these. Yeah, so what we want to do now is do some parsing. Fn parse machine. We're going to do a parse machine, which will return us, take it some data, 8. It will return. I think it would be nice to get a vector of vectors. I don't know if that really works. Const coordinate pair, which equals vector of length 2 and I don't know, 60 coordinates. Ooh. Okay. Actually, it'd be like U16 if we structured it so all the x's were together and all the y's were together. Then we do like U16 by 3. And then coordinate pairs. Let's do that. And that is 2 of those. So that would get us the 6 values we need. And we just set that, no. So yeah, if we look at this, what we are doing when we parse this data out is, let's see, test data. I'm going to parse up to the plus. Button, prize. In fact, we could just parse this. Yeah. Okay, go to the X. What's next? Then get the rest. Go to the Y. What's next? Parse button. This is going to return. Problem is I'm parsing X's and then Y's, but you know what? It's going to be the way we're going to do it. It's going to return a U16, U16. Data, see. X split equals data dot split X. Split. Oh, no. Standard dot mem dot split scalar data y, and then so we're gonna do we don't care about that. We don't care about what's first. We do what's next. X dot X split dot next. I'm going to say it's going to probably split everything after the comma. Standard dot mem dot split scalar OU8. Wait. The buffer here is going to be split dot next. I'm calling it Y split because the next one is going to be what we want to look at. Maybe it's like after X split. There's got to be a better way to do this. Standard zig min. We just get like the index of X, the index of Y. That's all we want to do. X start equals the index of data, and the haystack is X. X and equals the same thing, but now we're looking for the comma. Y and equals that index of, and this could be to do this in one pass. Data is neatly ordered. Data okay. Then what we would do is X equals standard or it's actually format parse int u16. The buff is going to be data X start +1 dot X end. Base is going to be 10. Expect the type expression found. Turn X, Y. Okay. Start. So now parsing the machine, we can do data, or we're going to split on new lines. split lines equals bar lines standard. Oh, and I forgot to put all this stuff here too. And that. Now we're going to tokenize this one. Tokenize scalar U8 data. And the delimiter is going to be new line. For line and for lines line. You know, all the time I type zig and write zig, you think I would not make that mistake by now. Music stopped. Just realized. Okay. Actually, it's going to be, we don't need to do that. We do. X, C bar, XA, YA equals const. Then parse price. Actually, it should be like so turn is direct also U16 and U16. And then this one, we're going to do something very similar. So for here, do to them. Const price, X price. Const. There we go. So now all we gotta do is do machines. Oh, we want to make a chord pair. Pairs equals or turn. And this is where I need to look about these vectors and zig. Let's take a look at the documents here. a vector. Oh, maybe we want to do something here if we could do that. Okay. Okay, now we want to do this. Global allocator. So we're gonna create an array list of chord pairs, and then what we'll do is split the data as well. Our data it. Actually, just call it iter. Data dot, or no, standard dot mem dot tokenized scalar weight data, and this is going to be actually one tokenize sequence. While iter.next machine list dot and parse machine. There we go. So what's it not like? Okay, so you can only use integer floats or bools, which is fine. We can then do chord pairs is actually just struct x, which is u163, y u3. Expect the type u8. Oh, okay, so this is a common error in Zig, or I guess maybe not error, but it's a common error you'll see, which is when you pass in a value, mutable values are more restrictive than constant values. It's the same in like Rust. You're a value, you can pass it in, and if you define it as mutable, then only mutable values can be passed in, so you can't pass a constant value in. So it's like that, but in reverse, in a way, because Zig doesn't declare variables as mutable, you declare them as const. And so when you declare, well, in the function declaration, right, if a variable is given, particularly when it comes to arrays of items. Here we have an array that technically all parameters in Zig are constant. But this is an array of constant U8s, which means the data inside the array can't change. But what I had said was I need an array of U8s where the values inside the array can change. And when I was passing, it was a constant one, and those don't match. I can't pass in something that can't change to something that may change. So that's why you have to add the constant in there. Which, ironically, is if I did have an array of non-constant U8s, I could pass it into parse machine or whatever, because this just tells the compiler U8 won't change, or the values inside the array won't change. So then you can still pass something variable where the values could change, because that doesn't break anything. Unless, you write bugs, but. Okay. So we've got our machine list parsed. Now we got to do is start testing, right? Go back to day 13. Oh, yeah. Need a number of button presses, 8,400 to be the same. So but when I press A, it changes X, and it changes both the X and the Y. So what we could do is go from 1 to 100, 1 to 100. I mean, that's going to be 10,000 operations on each of these. Should be a lot. And test. Let's see, press buttons in X, in Y, size U8, 8. Cost X. Cost A is 3. It's going to return an optional optional U16. U size. Okay. Pairs. Okay. So now what we can do is you know what? I do want these to be I think A, B, and prize. Okay. Prize, and what we'll change now here is that I don't even need to do that because I could just change it here. Change this to return a U16 by 2. A, B, prize. Is it not like? What am I missing? Oh, that's what I'm mixing. There we go. If in X times pairs.x or A. Yeah, pairs.A. It should be in Y and in A and in B. Right. So the number of times we multiply that by A plus in B times pairs.b equals pairs.price. I don't know if you can do this, but we'll see. Then return optional of we're going to return the total cost, which is in A times cost A plus in B times cost B. I gotta remember what we're doing here. So for the second, fourth claw machines, there's a good combination of A and B prices that will earn a prize. For third claw machine, the cheapest way to win prize. So the most prizes you could possibly win is 2. And tokens you have to spend to win all prizes is 480. What is the fewest tokens you'd have to spend to win all possible prizes? Okay. And so we're going to do var token cost equals null. It's a size. For 0 through 100. Call this in A. For 0 through 100. Call this in B. Cost if cost or if press buttons in A in B. Oh, and it's for every machine list. For machine list items. Machine actually. Okay, if that is true, then we get a cost. And so then if cost is not pretty, it's greater than token cost, or it's less than token cost. If token cost equals null, or if it equals null, then we're going to set it. Cost equals cost. If it's not null, it means there's a value there we need to check is cost less than token cost. If it is, then we're going to do it. Okay. And then once we're done, we need to if token cost answer plus equals cost. Which means answer needs to be a variable now. And it needs to be resize. We try this. Truncate. I do truncate because I know that these values cannot be bigger than a UH. Oh, we gotta assert that it's not there, that it's not null. Mixed scalar and vector operands, U8 and vector. Okay, that's where I need to learn about scalars a bit, or vectors. So C equals A plus B. Oh, it is prohibited. Sig provides the splat built in. Produce a vector where each element in the value scalar. Return type and thus length of the vector is inferred. Okay, so you might need to do some splatting. And res 1 equals res 1. Okay. Expected const found optional const. Oh. Yeah, we're going to just assert that theta is well formatted. Expected 3 arguments found 2. Oh. It does not like. Expected const found comp time int. Once again, we're going to assert that these are all well formed. Got to try those, which means we get errors here. Okay. Okay, that's moving. Says start index. Oops. That was a mistake. Okay, we got it. Doing this with 5 is a lot faster than doing it with or just 4. You're only doing 40,000 versus what's prod? How many? There's a lot. 12,077 divided by 4. What's that? 319. 119 times 10,000 is a lot. 3 million. Oh, I'm an idiot. Standard.debug.print. That was a lot faster. I always forget to add new lines here. 38839. Let's test that out. Right, we are. As you go to win the first prize, you discover that the claw is nowhere near where you expect it to be. Due to the unit conversion error, your measurements, the position of every prize is actually see, let's look at this. Hundreds, thousands, millions, billions, 10 trillion times higher on both X and Y axis. Add 10 trillion to the XY position of every prize. After making this change, the example would now look like this. Now, it is only possible to win prize on the second and fourth claw machines. Unfortunately, it will take many more than 100 presses to do so. Okay, so we brute forced the first part, and as we expect, there is no way to do that here. So we gotta go back to the drawing board here. Because I expected this, but it's still a bit of a kick in the gut. Oh man, that's a lot of tokens too. It's not actually 10,000. See, here's the thing: is it was a multiplicative error, right? They could talk about a unit conversion error, but it's not a unit conversion error. We're just adding 10 trillion to every value. So it's not like you could figure it out by just multiplying our answer by 10 trillion. Ugh. Minimizing. They say it's nice here or convenient here. I mean, for the question that the X is always larger on one and smaller on, and then the Y is always smaller. So it's not like you just pick do B all the time, because if B was just the better choice all the time, you'd pick it. So what you want to do to optimize this is this. Actually, it kind of reminds me of some game theory. Okay. Right? Because we have X. Let's not do that. Let's not. We have Y. We have X. And we'll start our 0, 0, because that's every problem starting at that origin. And as we go, excuse me. Right, we have two strategies, or rather, I guess I should say. This is A. Maybe let's see if I can draw this out. Let's talk what I'm thinking about. And B. Okay. So when we go, 10B and 10A, we're going to get here. Yeah. So we have a Y and X. And for the sake of simplicity here, we're going to do this. So we have cost. We have the target. And we have what we can, our strategies. Okay. Our cost is 3, 1. Strategies are A, B. And our goal is to get to the target. Now, strategy A is going to give us some XA by YA change. Closer to what we want to get. Same with B. It's going to do an XB, YB. And what we want to know is the ratio of these, right? Because if we want to minimize cost, we're going to get the minimum cost. We want to know how much, what's the relative cost of A to B matched with the value that we get out of it, right? How much closer do we get to the thing? I mean, this would work if we knew we could create them with these costs. So let's try to think about what could happen here. Here we have our X and our Y. We're going to put our price over here. So we start here. We'll put strategy A and strategy B. Okay, so start with A. A, maybe we step here and here. No, we'll put that one. We just did A's. Yeah. Kind of get a line that says, hey, you know what? We just do A's. It's not possible. Maybe B is like this. Right. If we just do B's, we also miss it. Would it be possible to then mix and match and then find what's the minimum mixing and matching, or that generates the minimum cost? That's a tough problem. Tough problem indeed. Well, I'm gonna cut the stream for today, but you oh, sorry, got weird texts. You have a good one. Good luck if you're on this problem, figuring it out. I'm gonna have to think about this. I'm gonna try not to cheat. You have a good day. See ya.